Good afternoon. I'll try to do it fast. The goal of my work was to create a surveillance sensor network with an ability of self-configuration, and we had to do this network reliable. To do that, we had to build an autonomous reliable sensor network, and for surveillance tests, we had to create a graphical user interface and set up a data storage where all the data will be saved. In current sensor networks, sensor nodes are not always protected from the rains and snow, and data is lost without network connection. And in the sensor networks where the data storage is mounted, there is no way to survey the data in real time. So we propose the following sensor network. So this network consists of sensor nodes. I'll tell about sensor node later. All sensor nodes are connected using ZigBee network, and this ZigBee network sends data to the data storage to the PC with the MySQL database, and back-end users, like operators, can receive this data using graphical user interface from the data storage using internet. So we connected ZigBee network and internet. This is hardware. Sensor node consists of mutable and immutable part. Immutable part is a microcontroller, wireless module, SD card adapter, LCD, and GPS module. And mutable part is different kinds of sensors. We can change sensors according to the task we have to solve. Now, here we are using like environmental sensors. To protect our sensor nodes from rain and snow, we developed two types of covers, cases. First case protects the sensor node from the light rain, but it allows us to mount sensors of different sizes. And second case, we developed for our sensors, which are not so big, so we could protect sensors by roof and walls, and actually this cover allows us to protect from the snow and more heavy rain. And usually the ZigBee network consists of coordinator, router, and end device, where coordinator, after initialization, becomes just router. We have decided to use different devices. Like we have sensor nodes, which are routers in classical ZigBee network. We have data storage, which is a PC with a MySQL database. And we have added a new type of sensor node called black box. Black box is a sensor node actually without sensors, but with SD card with high capacity. This black box gathers data from all the sensor nodes and stores this data. So in this way, we can store the data in the sensor node on SD card, in black box, and in the data storage in the server. Actually, speed of ZigBee network is 250 kilobytes per second, but I'm using ERAS-232 protocol in my hardware, so the real speed is 9.6 kilobytes per second. And ZigBee networks gives us features as automatic pathfinding and broadcasting. We're using the simple data protocol where we send the sensor node name, consists of 4 bytes, and environmental data and GPS data. GPS data is sent in NMEA format, GPRMC table. To make our network more reliable, we use overlapping. Every sensor node should have more than one way to the data storage. So if one sensor node fails, the ZigBee protocol allows us to automatically search for the new way. So to make it possible, we use at least 2 ways to the main data storage. If sensor node fails, so we use overlapping. If sensor node is totally destroyed, we don't lose the data which was gathered by the sensor node, because the data is duplicated to the black box and to the server. And if connection is lost, the sensor node continues its work. It logs its data to SD card and can be retrieved later after the connection is restored. In extreme situation, we try to decrease delays in the sensor network. Extreme situation is when temperature is too high or poisonous gas concentrations is too high. So all the sensor nodes that receive data like high temperature and high gas concentration, they send data, but other sensor nodes stop sending their own data. They just retransmit this data to decrease delays. And for security purposes, we can use whitelist. Every sensor node has its own hard-coded ID, and we can create whitelists to prevent other like bad guys to read our data, our own data, and they will not be able to send commands to our sensor node. And in the first stage of network initialization, the black box is automatically chosen by using the ID of the sensor node. And we have created the user interface which shows like the map, and each sensor node position is shown by the green pin, and the environmental parameters are presented by the circle, by its color, by radius and thickness. And user can choose whether he wants color to represent temperature, humidity, or other parameters. And we can show many kinds of maps, actually. And we use cache to decrease the network load. And user can choose different kind of maps, and here we input test data to show how it's easily to understand what's happening in this area. We chose the color represents the poisonous gases concentration, and here we can see that concentration is high, and when the color is red, we can see that concentration is too high, it's extreme situation. So operator doesn't have to read always these numbers, these monochrome numbers. It can intuitively understand what's happening in the area. And the user interface can draw charts which show how the parameters change during long period. He can put some marks, and he can see real information in the table. And we provided some tests. Every node entered the network in 5 to 10 seconds according to the distance to the router. And we have tested 9 wireless modules. The modules were Sina Company Pro B modules. They are the same modules, but they all had different distances. In urban conditions, the weather was really nice, but the maximum distance was 464 meters, but in datasheet, the producer said that maximum distance is 1.6 kilometers. So we didn't believe them. We checked, the maximum distance is 464 meters. In fog conditions, the maximum communication distance decreased to 220 meters. And in park area, when the view was fully closed by trees, the maximum distance was 180 meters, 20 meters. And inside the building, the maximum distance is 50 meters. To make our communication error-free, we had to check which minimum delays we can use between we send the second portion of the data. So when we send data from one sensor node to one server without retransmission, with the message length 90 bytes, we have to have delay 330 milliseconds. But when we send the command with 2 bytes message, we can decrease the delay to 100 milliseconds. But when we use one sensor node and 2 servers, the delay decreased 5 times more, 1.5 seconds. So we think it's better to use only one server and one black box. Otherwise, we highly increase the delays in our network. And with 4-point retransmission, when one sensor node sends data and 2 other sensor nodes retransmitted data, the delay has to be at least 3 seconds. Otherwise, we start to lose our data. And with 9 sensor nodes, with 3-point retransmission, we have to have 6 seconds delays. Otherwise, we lose the data. So on the server, we used kind of old computer, and our database had about 500,000 records. And to read data, to read 10 records from our database, it takes only 50 milliseconds. But if we want to draw a chart on user interface, we need to read 100,000 records, it takes 2 seconds to read this data. And we have tested user interface on the netbook. And on netbook, it worked fine. It took only 30 megabytes of RAM and 40% of processor time. And we have tested sensors, like temperature and humidity, it's one sensor, it's MEMS. It starts showing real data from the scratch, from after we gave him power. But gas and smoke sensors, they're old school sensors which use resistors. It takes long time to start showing real data. Uh, it took about 1.5 hours for smoke sensor to reach steady state, and about like 2 hours for gas sensor to reach steady state. So our sensor node actually can work after 2 hours of operating. But when we first bought these sensors, we had to wait for 6 and 7 hours for these two sensors to reach steady state. So actually in future we have to use only MEMS which show real data from the start. We have conducted like outdoor tests, and we can see here the high peak for smoke sensor. At that time, like person smoked near the sensor, so for test purposes. But because of this problem, we cannot really distinguish whether the extrinsication appeared or the sensor node just needs time for warming up. It's like drawback of old style sensors. And we have conducted outdoor tests for a long time, and here we can see that gas concentration increased to 80%. This shows like the poisonous gas concentration increase and it's dangerous place. And first, we didn't understand why it happened. Like first day, it was everything okay. Like humidity changed according to the day of time, and temperature, gas, and small concentration were in normal. But later on, we started to use the air conditioning. It was summer, and temperature decreased to like 22 degrees Celsius. But concentration of poisonous gases started to increase. And day by day, we can see concentration of smoke and gas increased really high. And gas sensor can show concentration of many gases, but gas and smoke sensor together show concentration of carbon monoxide. So we state that air conditioning filters still cannot really filter carbon monoxide poisonous gas if we look at these results. But temperature and humidity sensor worked fine, and gas and smoke sensor finally started to work, and they showed like high concentration after we started to use air conditioning. Conclusions. The proposed sensor network could overcome some drawbacks of other researchers' networks. It's programmed to be stable and useful even in emergency cases. Thanks to server-client structure, the data can be accessed in real time by many operators, and protected casing was developed. User-friendly graphical interface was developed, and black box was introduced to the network. In previous networks, they didn't try to use any kind of black box, any kind of login. In the future work, we want to develop an augmented reality system for environmental conditions surveillance on mobile devices. And we want to combine our proposed method of reliable network communication with the flexibility of unmanned aerial vehicles based on the multi-agent concept in mobile autonomous surveillance system. Thank you.
I have a question.
Yes.
When you collect the sensor data, that's coming as real numbers or integer numbers or bytes or vectors?
We have like two kinds of sensors, MEMS and analytic sensors. MEMS gives us digital data. We use its own protocol. We use just library from the company which created this sensor. They give us actually temperature like 23 degrees and humidity 80%. But to other sensors, gas and smoke sensor give us voltage from 0 to 5 volts. We have to use ADC to show real numbers using that voltage.
And when you collect the data on your database, the database routine itself based on Zigbee communication or?
Database, this server, it has like internet connection to share its data, and we use the USB dongle which can connect to the Zigbee network. And this dongle uses RS-232, serial communication.
Interesting. So you're using MySQL over there?
Yes, I'm using MySQL, and to program microcontrollers, I use plain C language.
Not legendo espanhol, tudo, né?